Today on this episode of The Brain Surgeon's Take, we will be discussing the AI revolution in weather forecasting with faculty in the Department of Atmospheric Sciences at the University of Miami, Dr. Michael Fischer. Learn how artificial intelligence is rapidly impacting meteorology and enhancing our ability to not only predict future climates, but also potentially giving us advanced warning of impending natural disasters. Much more on this podcast episode. Welcome back, everyone. Here's my take on Dr. Michael Fischer. He is a leader, integrating old school meteorology with new school atmospheric science. Michael is a pioneer in AI-driven weather models, using artificial intelligence to create accurate weather predictions days, weeks, and even months into the future. The obvious advantage of this advancing technology is our enhanced ability to know what our local weather patterns will be. But the way more important factor will be forecasting imminent natural disasters, such as hurricanes, tornadoes, floods, and forest fires. This interview got me thinking about what the future of meteorology will look like. If AI continues to evolve, we might be able to mitigate catastrophic natural disasters by having advanced warning. So much potential, so much promise, yet so much work remains to be done. Listen up as we discuss the AI revolution in weather forecasting. Check it out. Hey, Michael, how are you?
Doing great. How are you doing?
I'm all right. Listen, thanks for joining us today. I'm excited to talk about your area of expertise, which is artificial intelligence and how it pertains to weather predictions and meteorology. So very excited to hear your insights on it.
Yeah, thanks for having me on. Looking forward to talking with you.
How did you first get interested in atmospheric sciences?
So I think I can trace that back to when I was a young child. I'm from Miami, Florida, and grew up in the Cutler Bay area. And so in 1992, that went through the northern eye wall of Hurricane Andrew, which was one of 4 Category 5 hurricanes on record to hit the U.S. So my house was really heavily damaged. So they had to totally rebuild it. And I couldn't live in it for about a year. And my first memories are of being a nearly 3-year-old boy and people repairing the roof of my house. And so I think in hindsight, I always had that curiosity of how could something be so strong that, to cause such destruction. And so ever since then, ever since I can remember, I've been interested in hurricanes. And so I went to college to continue to study that.
Now, moving into AI, because I feel like AI is everywhere these days. It's in every single part of our lives. AI seems to be creeping in. How is AI currently used in weather predictions?
So that's really a quickly growing field. Um, it's used in a wide range of applications. So we have models that are completely AI based. We have hybrid models that use kind of traditional numerical weather prediction with components that are AI based. And we also use AI to quality control some of the observations that are ingested into the numerical weather prediction models. So I don't know if there's an area that you want me to talk a little bit more in detail, but there's kind of multiple different avenues here.
Well, I guess let's talk about comparing AI to the older, more traditional models. Is AI that much more accurate when you're predicting short-term weather events? So the stuff you see on the news, right? The stuff that really is important to all of us, like, is it going to rain today, tomorrow? What's the weather over the weekend? How much more accurate is AI than the typical models which we've been using?
So it's a great question. Yeah, AI is kind of a lot like the weather. Like it's quickly evolving. If you don't like it, just wait a few minutes, you'll get a different answer. So that's really, especially in the nowcasting regime, there's been, I think, rapid improvements in that area. For example, last year, NVIDIA had a model that came out called Stormcast, I believe it was called, that made forecasts on the time scale of 1 to 6 hours. So kind of like trying to predict, is a thunderstorm going to move over my house over the next couple hours? And that paper demonstrated that their AI model had skill that was comparable to some of the leading traditional numerical weather prediction models. And there's been other models that, if you talk about forecasting over longer time scales, like in the order of about 10 days, that, for example, Google DeepMind had a paper come out last month, actually, that showed they can beat the leading numerical weather prediction model, the Ensemble from the European Center. If you look over 1,000 different metrics, over 97% of the time, their forecasts were more accurate. than the traditional numerical weather prediction model.
Are the current weather stations integrating AI with a more traditional model, or are they just going strictly AI, or are they going strictly traditional?
So there's I would say all of those. There's models that are still most of the operational models are kind of traditional numerical weather prediction models. There's also, for example, the European Center has their AIFS model that is run in real time, that is AI based. And there's also models that, I guess it'd be helpful to give a little bit of background about how traditional numerical weather prediction models work. Basically, they have cubes set up over all across the globe, if we're talking about a global weather prediction model. And so they're trying to forecast what is the weather going to be like in that cube at different lead times. And so these hybrid models that use traditional numerical weather prediction platforms in conjunction with AI tools, there's processes that occur within those cubes that the model can't resolve. Like, let's say the cube has a size of like 25 kilometers on each side. If we're talking about processes that are occurring like in the individual raindrop or ice crystal in a cloud, right, that's not going to be resolved in that cube. So the AI model can be trained to essentially learn the patterns that occur, like with the physics that are occurring in those smaller scales, to resolve the processes that can't be explicitly resolved in that individual cube. So for processes that occur on the spatial size of that cube, you use traditional numerical weather prediction models that follow the laws of physics, but then you can use machine learning approaches to kind of resolve those smaller scale processes. And that's what a lot of these hybrid platforms use.
Do you think that we will be moving towards strictly AI, or do you think that traditional model will always be the base?
So that's a great question. That's kind of there's been a lot of good debate I've read recently on that. I think the consensus is that there's going to be, at least for the short term, these traditional numerical weather prediction models are going to be heavily used upon, because there is some merit from a forecasting perspective, knowing what are the limitations of the model, knowing certain kind of regimes that it tends to struggle in and certain regimes that it does well in. And so these models have been around for years now, decades now. And so we know kind of when to really trust the model and when not to. The human has learned that. But that being said, if the AI model with time, as they prove that they can consistently provide valuable forecasts, and you see just kind of over the last year or so, even the growth of these AI models and the improvement in skill, I personally think that that's the future, and we're going to see a shift towards more heavy weights on AI models. But that just really depends also on the rate at which AI technologies advance over the next decade or so.
I guess the major benefit to AI, if you agree, and I think the thing that is most important is not just daily weather, but the real catastrophic events, the real extreme weather. So hurricanes, tornadoes, heat waves, even forest fires, that type of stuff. Is AI going to help us in predicting those with even more lead time that would benefit society?
So that's the hope. And there's some signs that that's happening. In some of these papers, for example, some of Google DeepMind's papers that came out within the last few months have looked at these extreme events, like, for example, tropical cyclones, hurricanes. And there's been evidence that they can predict these events with greater accuracy and potentially greater lead time than some of our leading traditional numerical weather prediction models. And that's a little surprising because, by definition, these extreme events are outliers. And so you need a lot of data for the AI model to work well. But it seems that we still have enough data for these models to predict these kind of outlier, these extreme events with some success. I think additional, study needs to be done on that to see, how consistent can we predict these extreme events with more accuracy. But I think the future is promising. And, even if, for example, like in a hurricane, if we can have an extra day of lead time, that would be incredibly valuable.
How much advanced warning do you think AI could grant us for extreme events? And not just necessarily now, but let's say as the technology advances 5 years from now, what's the hope of the lead time that we would get for these extreme events?
I think the hope is that we essentially reach the predictability limit. And so let me try and briefly explain what I mean by that. Atmospheric phenomena have a certain degree of predictability. Like, we'll probably never be able to predict a hurricane, like a month in advance, precisely where it's going to move. And that's because we don't have perfect observations of the atmospheric state and the oceanic state, the land state, everywhere in the world at every single molecular level. And so those uncertainties quickly grow upscale. And so this is often what's called like the butterfly effect, where a butterfly flaps its wings over some place like in like the Central Plains, and then that leads to a tornado like a week later, because these turbulent eddies can grow upscale and influence the weather patterns. Um, so there's limits at which we can predict phenomena, but we're not really at those limits yet. So the hope is that maybe these AI models can help us get closer to those limits. So maybe if we have a hurricane forecast that's accurate 4 days in advance, maybe we can get 5 days in advance. So there's a limit, but hopefully we can at least get closer to what that limit is.
What could a I mean, was AI used at all in looking at the California, LA forest fires? Is that something that could have potentially been predicted earlier, given a more lead time?
So, admittedly, this is a little outside of my area of expertise with wildfires, but I have seen multiple studies that have used AI to try and predict, wildfire occurrence, both on like week timescales in advance. Also, what's called like super nowcasting, where you can use high resolution satellite imagery and predict wildfire growth on the timescale of like minutes to hours in the lead time. So there's projects that are actively looking at that. I also know that the conditions, like the recipe to have rapid fire spread, were in place. The National Weather Service there was advertising that days in advance, so we knew that the conditions were there. But really, kind of ultimately depends on where those fires initiate, and then the local conditions for how those spread.
What are the limitations of AI, right? It's a term that we use. Okay, AI will just take the data and it'll forecast everything. What are the limitations currently of AI when it comes to forecasting weather?
So that's a great question. I would say largely it's kind of twofold. The primary limitation is the data that it's trained on. Um, so right now, a lot of these AI models, especially that are predicting like global weather phenomena, they're trained on what's called a reanalysis. Usually, the European Center's reanalysis, the ERA 5. And so that is historical data every hour for the last 40 to 50 years or so that these models are trained on. And so that tells the model, when the weather pattern looks like this is how temperature tends to change. This is how the winds tend to change. But that data that it's trained on has errors. It has uncertainty. It has biases. And so any errors in that training data, the model is also going to pick up on that. So that's going to be a limitation. So if we continue to improve the quality of the data that these models are trained on, that will hopefully lead to better forecasts. Also, a secondary component is compute. The models it take a while to train, and if we have more powerful computation, perhaps we can have more robust training and evaluation of these models that could also improve their skill as well.
I mean, since data, basically garbage in, garbage out, or quality in, quality out, since AI is completely dependent upon the data that it's interpreting, what are the potential ethical concerns regarding data privacy and biases when you're talking about AI in weather predictions?
Another great question. I would say maybe slightly naively that the privacy concerns are not as extreme. They're certainly there, but not as extreme as some areas like healthcare and things like that. Um, the bias component is certainly very real in training and evaluation of the model and its forecasts. We talked a little bit about this before, but for example, like something that I do work with hurricanes. We know that in the historical record, hurricane frequency tended to be undercounted before the satellite era. So if you go back to like the 40s, 1940s, 1950s, we have a smaller frequency of hurricane activity that we see in the modern era. When I say hurricane frequency, obviously I'm including like tropical storms and weaker cyclones. So if you just look at the raw count, you'd think that, there's been this increase in hurricane activity, potentially due to climate change and other things, but there's also, technological limitations. And so things like that have to be considered when you're training a model. There's even things as kind of surprising as if you look at when hurricanes or tropical cyclones are first classified, there tends to be a bias that there's a greater frequency that are classified right around sunrise as opposed to sunset. So you say, why is that the case? Do hurricanes just naturally form around sunrise? Well, it turns out that some of the satellite imagery we use, visible satellite imagery, isn't available till the sun comes up. And that allows us to get a better idea of, is a closed circulation present? That's one of the criterion to have a tropical cyclone. So there's these like kind of biases that are woven into the data due to just human practices that have to be accounted for when you're training and evaluating these models. And so that's why it's really important to have domain experts in the evaluations of these weather models, because they know some of these intricacies that go on in the classification of these systems. So it's a really complex problem. I will say there's groups that are dedicated solely to having trustworthy AI models that are as bias free as possible. For example, Dr. Amy McGovern's group at University of Oklahoma is partnered with the National Science Foundation, and they're actively investigating this. And they've had a series of really nice papers that have come up over the last couple of years that have kind of explored the problem of bias in AI and weather forecasting.
Now, you covered bias, but what about the interpretability? So, how do we ensure and understand the reasoning behind these predictions, right? It's a machine that's taking the data and coming up with these predictions, but how do we understand the reasoning behind these predictions?
That's a significant challenge. That is something that's a subject of active work. Folks are doing that. There are methods to try and extract, what's causing the forecast to come out a certain way as opposed to other. How does slight changes in the initial conditions lead to different outcomes? And so that's a subject of ongoing work. But that is, I would say, a problem with AI in general in any arena, not just weather forecasting, but any kind of application of AI. I will argue that to some extent, I do think kind of traditional numerical weather prediction has that black box component to some extent as well. A traditional numerical weather prediction model is solving millions and millions of equations. And so there's a reason we're using a computer, not a human, to make these forecasts. And so it's difficult to say, how does this one specific equation affect the forecast? And so, we can do sensitivity tests and look at, how does this one kind of physics component influence a forecast? But for any given forecast, it's hard to really isolate, the influence of one kind of portion of the forecast and how that influence, things that happen 5 days later. So that's something that's kind of just baked into weather forecasting. I'm not saying that's not important to identify, but that's kind of been an ongoing issue, I guess I'll say.
Now, as AI increases, and we touched base on this a little earlier, what is the role of the human meteorologist interpreting and refining these AI generated predictions?
I think it's largely what you just said. Humans are probably going to have more of interpreting and messaging responsibility as opposed to maybe more of kind of a traditional forecasting responsibility. So what do I mean by that? Is that we have this guidance. So we have a combination of traditional numerical weather prediction models, and we have more and more AI models coming online. And so the human has to figure out how to distill all that information and come up with a deterministic forecast. So say a specific temperature and wind speed at a given location, as well as probabilistic forecasts. And so the models can help with that. But the messaging, I think, is the key component. So you can have a perfect forecast. Let's say, again, in the case of a hurricane, we can know maybe that a hurricane is going to hit, say, hypothetically, Miami, Florida. Let's hope that doesn't happen in like 4 days' time in the year 2026, let's say, in a couple of years, or next year, actually. But, if you're not properly conveying the threat, what about the areas just north of Miami, like in Broward County? What kind of wind speeds are they going to be experiencing? You can have the perfect forecast in the model, but that's not properly conveyed to the public in a way that they can trust and understand. They're not going to act on that. And you're not going to be saving lives and property in the process. So I think humans are really tasked with kind of building that bridge between what the weather models are saying and conveying that in a way that the public can understand. And so that's going to be increasingly important as we go into the future, I think.
So, AI, robotics, technology are all amazing, but there is the threat to job market, right? And what the humans are doing. And we have the same problem here in medicine, where I know pathology and radiology, which are all pattern recognition, AI has proven to be exceptional and is a real threat towards human physicians that do pathology and do radiology. Um, are meteorologists also under fire? Do you feel like meteorologists over time, this is not this year or next year, but over time, 10, 15, 20 years, will they eventually become extinct and there won't be a need for a human meteorologist? It'll all just be computer and robotic AI based.
So maybe I'm a little biased, but I think there's always going to be need for a human meteorologist. Even kind of what we were just talking about before with the messaging component of things. But again, we also talked about the importance of having that domain expertise and knowing the limitations of models and how to train these AI models. So I think there's always going to be need for meteorologists, at least in the immediate short term. There might be a few jobs that are automated due to AI for various reasons. But I think, when we're talking about forecasting severe weather, whether it be tornadoes, thunderstorms, hurricanes, things like that, or heat waves, that messaging is critical. And so humans are going to still be at the forefront of that. Maybe AI can help provide tools to help us more effectively provide that communication. But humans are really going to be important there. I also kind of like what the CEO of NVIDIA said a couple months ago. He said that AI may not take your job, but people who use AI might. And so I think that could be true in some cases. Maybe, some traditional weather forecasting positions are replaced by people who are still meteorologists, but people who have more expertise using AI and how they can more effectively harness the current tools to have more accurate forecasts. So I think that's why training in AI is going to be especially important over the next decade or so.
Yeah, I think you said it best. You can't be afraid of the technology. You have to embrace it. That goes for all fields, and we see it here in medicine that when there's a new technology or there's robotics or AI in medicine, a lot of the older generation push it away like, oh, that's ridiculous, and at the end of the day they're going to end up becoming extinct because if you're not adopting new technology, like you said, maybe that technology won't take your job, but people that use that technology will. So that was great to hear that from your end. What are some of the most promising areas of research in AI weather forecasting?
Yeah, I think there's kind of a range here. So I guess I'll give kind of a personal anecdote here. So my group works with observations collected by NOAA's Hurricane Hunter aircraft. And so these people routinely fly in to the center of storms, collect data that's very valuable in assessing the intensity and structure of the storm. Um, but that data is limited. We don't always have an aircraft out there. And so we don't always have observations, but we can use some machine learning methods to generate synthetic data. So based upon the data we've collected over the last few decades, we can learn, for example, how is the wind speeds measured by the radar related to, for example, the satellite structure, which we always have observations of. There's always geostationary satellites in space that are constantly collecting new satellite snapshots. So if we can learn the relationship between the wind structure of the storm and its satellite signature, we can then have the machine learning model have estimates of what the wind structure is, even for times when the aircraft is not out there. And we can do that for basins that are not routinely sampled by aircraft potentially. For example, like in the southern hemisphere, there's traditionally been no aircraft reconnaissance observations of tropical cyclones there, even though tropical cyclones do occur there and impact land. And so we can harness AI to provide additional situational awareness of what the structure of these storms look like to help forecasters in those regions and people impacted by those storms. We can even potentially use these synthetic data as pseudo observations to be ingested by both traditional numerical weather prediction models and these AI based models to hopefully have a more accurate initial state of the atmosphere. And that could lead to more accurate forecasts in time. And so that's one kind of platform. I would say also just in general with these AI tools, they can run so quickly. For example, the expensive part is training the AI model. But once the AI model is trained, you can run this model theoretically on like a desktop computer. And for example, some of the Google DeepMind predictions are made in like the time scale of 10 minutes on using like a single AI chip on the cloud. Whereas traditional numerical weather prediction models are using these very expensive supercomputers that take hours and hours to run. They're solving millions of equations. And so you can run these AI models very quickly. You can potentially generate ensemble forecasts. So if you have like uncertainty in the initial state of the atmosphere, you can kind of try and account for what that uncertainty is and have a range of potential forecast outcomes. So you can have a probability of maybe hurricane force winds at a location or probability of freezing conditions at a given farm or something like that. And so these can be run very inexpensively potentially after the model is trained. And so that could help locations that maybe don't have access to these supercomputers. They can potentially have, maybe localized forecasts that can help them. For example, areas like the global south that have been traditionally, have struggled and have had less accurate forecasts in those regions, they might benefit from some of these AI potentials. So it's kind of a wide range of avenues that AI is really exciting. And so I'm really curious to see how it shakes out.
Other than your group, which is obviously at the forefront, what other groups nationally are really leading AI weather forecasting?
So I would say this is really an emerging field. I don't necessarily want to single out specific groups and leave some out. I know that I did mention Dr. Amy McGovern's work at the University of Oklahoma. They're partnered with the National Science Foundation. They've done a ton of excellent work and have had multiple good review papers on atmospheric science. I'm biased to my colleagues that are more familiar with in the States, but there's also a lot of great work going on in Europe as well. I would say Dr. Libby Barnes at Colorado State has done outstanding work at helping what we talked about earlier with the interpretability of AI, especially in the climate scale. So I would say there's really a growing component of work being done trying to leverage these AI tools, whether it be at the University of Miami, where I am, or other institutions, to not only have more accurate forecasts, but just really better understand atmospheric phenomena and what's going on.
Any other countries heavily involved in this research that you know of? Any other countries that are pioneers and pushing the frontiers?
I think it's really honestly kind of like an international effort at this point. It's kind of I think everyone in the world's kind of recognized the utility of AI, and so all these large tech companies all over the world are really harnessing AI, trying to come up with new platforms. I think universities all over the world are trying to come up with ways to leverage AI. Like, for example, I'm actively recruiting PhD students this year, and I've had applicants from Africa, from Southeast Asia, from all over the world that already have experience at the undergraduate level working with some machine
Wow.
learning tools. And it's blown my mind. Like, I wasn't an undergrad that long ago, and I just think of myself and now what these students are using, and it's really exciting to me, honestly, to see how quickly this has been embraced, and to see the enthusiasm for the younger generation. And I think, there's a lot of risks that come with AI, but there's also a lot of promise. And so if we can use these tools in a trustworthy manner, I think the future is bright.
Now, what are your predictions in the next, let's say, 10, 15 years? It's such an early field. There's so much potential. What kind of breakthroughs do you personally see happening in the next 10 years that are really going to change how we predict weather utilizing AI?
So I love this question. I think to a large extent, it's going to depend on just the rate at which AI grows. And so I'll give kind of an example of what I mean by that. There's talks, and again, this is a little definitely outside of my area of expertise, but with AI, talking about AGI, artificial general intelligence, and the possibility of AI agents not being that far off potentially, maybe on the next 5 years or so. There's disagreement over when people think that's going to occur, if it ever occurs. But if we have AI agents running around helping us perform our research, we could be incredibly more efficient as scientists and have breakthroughs at a rate that we didn't really think was possible. So it depends, I think, at the rate at which AI technology advances. Um, I think even in the absence of that, if you just look at the rate of growth over the last couple of years, and how quickly these models have grown in their forecast capabilities, I think personally that in 10 years from now, I think all the leading models are going to be AI based, or at least a hybrid model that have AI components mixed with kind of the physics based traditional numerical weather prediction models. Um, and I hope that it's going to allow us to push to higher resolution, better spatial scales, that we can resolve processes occurring on, like the thunderstorm level, things like that, at a global, for a global model. I think, and have ensembles of that, trying to mimic the uncertainty in the atmosphere. So we can have, like a probabilistic chance of a thunderstorm at your house or anywhere in the world potentially. It remains to be seen how skillful that is, but I think we're going to try and be pushing towards that. Um, Maybe 10 years from now is a little optimistic to have that achieved. And we're talking about relatively short time scales when we're doing thunderstorm forecasting, but I think just really pushing the envelope of what we're doing now and having more and more AI models utilized in that.
Such an amazing interview, Michael. Thank you so much for joining us. I think the take home points are, we all turn on the news, we see the weather, we watch CNN or the Weather Channel. I don't think people realize the amount of science, the incredible amount of science that goes into it. And that's only increasing. I think the importance of what you do and what your research is doing is really highlighted by climate change and these devastating natural disasters that are only happening more frequently. And I think that's very clear. The amount of hurricanes and tornadoes and tsunamis and forest fires. I mean, I feel like it's every other week there's another, cataclysmic environmental event. So I think the research that you're doing, your group is doing, that the university is doing, is really important, to help protect our society, but also just to improve our overall quality of life and know what the weather is going to be and when these extreme events happen.
Yeah, I agree. As the climate's changing, we're exposed to kind of just this new regime of weather. And so it's going to be increasingly important to have more accurate forecasts as these systems, potentially the ceiling on them becomes a little bit higher. Um, I will say regarding AI, though, that's another area that's important. These models are trained on historical weather. And as we enter potentially a new regime or some new scenarios that the model has never seen before, it's unclear how accurate it's going to be able to forecast that. So that's going to be the subject of future work too, is trying to make sure we have reliable forecasts as the climate's continuing to change, and hopefully continue to provide guidance that can help save people's lives in these extreme events.
Yeah, anyone who says that climate change is not a real thing, I don't know what rock they're living under. I mean, you just turn on the news and you're like, every day there's something new going on that that you've never seen or heard of or was incredibly rare, and now it's incredibly common. So, yeah, really crazy times, and I appreciate all the work that you're doing. So, thanks for your time, Michael. I really appreciate it. Great interview.
Thank you. Appreciate it. Thanks for having me on. Take care.